Estimating wire footage accurately is crucial for large residential electrical projects to avoid under-budgeting and material waste. To estimate the amount of wire needed, several factors must be considered. Firstly, square footage is a primary driver, as larger homes generally require more wire due to increased distances and more extensive circuitry. Secondly, the number of rooms directly impacts wire usage, with more rooms necessitating more circuits and consequently greater wire length. Thirdly, the complexity of the wiring system is a significant factor. Homes with extensive lighting, smart home integration, or specialized electrical features demand more wire. Fourthly, adherence to building code requirements is non-negotiable. Local building codes dictate minimum wire requirements for various circuits, ensuring safety and compliance. To apply these factors, let's consider two specific houses. House 1, at 8,000 square feet, can be estimated using an average of 1.25 linear feet of wire per square foot, which is a reasonable benchmark for luxury homes. This calculation yields 8,000 square feet multiplied by 1.25 feet per square foot, equaling 10,000 linear feet. House 2, comprising 6,000 square feet with an additional mother-in-law suite and a commercial kitchen, requires a slightly more nuanced approach. The base estimate for the 6,000 square feet is also calculated at 1.25 feet per square foot, resulting in 7,500 linear feet. Given the additional electrical demands of the mother-in-law suite and the commercial kitchen, it's prudent to add percentage-based allowances. A 15% increase for the mother-in-law suite and a 25% increase for the commercial kitchen are reasonable adjustments. Thus, the calculation becomes 7,500 linear feet multiplied by 1 plus 0.15 plus 0.25, which equals 10,688 linear feet. Summing the estimates for both houses, we have 10,000 linear feet for House 1 and 10,688 linear feet for House 2, resulting in a total estimated wire footage of 20,688 linear feet. When purchasing wire, 1,000-foot spools are a practical choice for large homes, providing ease of handling and minimizing waste. To determine the number of spools required, divide the total estimated wire footage by the length of each spool. In this case, 20,688 feet divided by 1,000 feet per spool equals approximately 21 spools. It is also prudent to allow for additional footage to accommodate unforeseen circumstances, design changes, or wiring errors. An extra 5 to 10% buffer can mitigate potential shortages. Furthermore, consider purchasing a mix of wire sizes, such as 12-2 and 14-2, to accommodate diverse circuit requirements. Different appliances and lighting fixtures necessitate varying wire gauges to ensure safe and efficient operation. If leftover wire is anticipated, factor in potential storage and handling costs. Proper storage is essential to prevent damage and maintain the integrity of the wire for future projects. Moreover, consider the specific electrical loads and circuit layouts for each house. General lighting circuits typically use 14-2 wire, while receptacle circuits and small appliance circuits often require 12-2 wire. Larger appliances, such as electric ranges and dryers, necessitate dedicated circuits with heavier gauge wires, such as 8-3 or 6-3, depending on their amperage. Calculate the amperage requirements for each appliance and consult the National Electrical Code, specifically Table 310.15b16, to determine the appropriate wire gauge based on the wire's ampacity. Also, factor in voltage drop, particularly for long circuit runs. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the resistance of the wire. Excessive voltage drop can cause appliances to malfunction or operate inefficiently. The National Electrical Code provides guidelines for voltage drop limitations. Typically, a maximum voltage drop of 3% for branch circuits and 5% for feeders is recommended. Use voltage drop calculators or consult electrical engineering resources to determine the appropriate wire size to minimize voltage drop for long circuit runs. Grounding is another critical aspect of electrical wiring. Ensure that all circuits are properly grounded to provide a safe path for fault current to return to the source, thereby minimizing the risk of electric shock. Use appropriately sized grounding conductors and follow National Electrical Code guidelines for grounding electrode systems. Also, consider the use of arc fault circuit interrupters and ground fault circuit interrupters to enhance safety. Arc fault circuit interrupters protect against fires caused by arcing faults, while ground fault circuit interrupters protect against electric shock caused by ground faults. Install arc fault circuit interrupters on branch circuits that serve bedrooms, living rooms, and other habitable areas, and install ground fault circuit interrupters in bathrooms, kitchens, and outdoor locations where there is a risk of exposure to moisture. Furthermore, plan the layout of electrical boxes and conduit runs carefully to minimize wire usage and ensure accessibility for future maintenance. Use strategically placed junction boxes to splice wires and avoid unnecessary wire runs. Also, consider the aesthetics of the wiring installation. Conceal wires within walls and ceilings whenever possible to create a clean and professional appearance. Use wire staples or cable ties to secure wires and prevent them from sagging or interfering with other building components. When pulling wire, use appropriate pulling lubricants to reduce friction and prevent damage to the wire insulation. Also, avoid overstressing the wire by pulling it too hard. Use pulling eyes or wire grips to distribute the pulling force evenly and prevent the wire from breaking. Always inspect wires for damage before installation. Check for cuts, abrasions, or other defects in the insulation. Do not use damaged wires, as they can pose a safety hazard. Label all circuits clearly at the electrical panel to facilitate identification and troubleshooting. Use a permanent marker or label maker to create clear and legible labels. Update the circuit directory whenever changes are made to the wiring system. Finally, ensure that all electrical work is performed by qualified and licensed electricians who are familiar with local building codes and safety regulations. Obtain all necessary permits and inspections to ensure compliance with applicable standards. Accurate wire estimation is also greatly impacted by the planning of home runs. Home runs are the wires that extend from an outlet or appliance directly back to the electrical panel. When planning these home runs, it's essential to consider the most direct and efficient routes to minimize wire usage. Avoid unnecessary bends or detours that increase wire length. When multiple outlets or appliances are located in close proximity, consider daisy chaining them together on a single circuit to reduce the number of home runs required. However, be mindful of the total load on the circuit to avoid overloading it. The National Electrical Code specifies maximum circuit loads and the number of outlets or appliances that can be connected to a single circuit. Another factor to consider is the type of wiring method used. Non-metallic sheath cable, or Romex, is commonly used in residential wiring for its ease of installation and cost-effectiveness. However, in some situations, it may be necessary to use conduit, such as electrical metallic tubing or rigid metal conduit, to protect wires from physical damage or environmental factors. Conduit is typically used in exposed locations, such as basements or garages, or in areas where there is a risk of moisture or corrosion. When using conduit, be sure to use the appropriate fittings and connectors to ensure a secure and watertight installation. The choice of wiring method can also affect wire usage. Conduit installations typically require more wire than non-metallic sheath cable installations due to the need to pull wires through the conduit. Also, consider the use of pre-wired cables or harnesses to simplify wiring installations. Pre-wired cables consist of multiple wires bundled together in a single jacket, making it easier to pull and terminate wires. Harnesses are custom-made assemblies of wires and connectors that are designed to fit specific applications. Pre-wired cables and harnesses can save time and labor, but they may be more expensive than individual wires. The layout of the electrical panel is another factor that can affect wire usage. Locate the electrical panel in a central location to minimize the length of home runs. Also, ensure that the electrical panel is easily accessible for maintenance and troubleshooting. The National Electrical Code specifies minimum clearances around electrical panels to ensure safe access. Furthermore, consider the use of subpanels to distribute electrical loads throughout the house. Subpanels are smaller electrical panels that are fed from the main electrical panel. They can be used to isolate specific circuits or to provide power to remote areas of the house. Subpanels can reduce wire usage by allowing shorter home runs from the subpanel to the outlets or appliances it serves. Also, consider the use of smart home technology to optimize wire usage. Smart home systems can automate lighting, temperature control, and other electrical functions, reducing energy consumption and wire usage. For example, motion sensors can turn off lights when a room is unoccupied, and smart thermostats can adjust the temperature based on occupancy patterns. These technologies can help to reduce the overall electrical load in the house, allowing for smaller wire sizes and fewer circuits. When estimating wire footage, it's also important to account for waste. Wire waste can occur due to cutting errors, damage to the wire, or changes in the wiring plan. A general rule of thumb is to add 10% to the estimated wire footage to account for waste. However, the amount of waste can vary depending on the experience of the electrician and the complexity of the wiring project. To minimize wire waste, it's important to plan the wiring layout carefully and to measure and cut wires accurately. Also, store wire properly to prevent damage and to keep it organized. Finally, consider the environmental impact of wire usage. Electrical wiring is a significant consumer of resources, including copper, aluminum, and plastic. By optimizing wire usage, it's possible to reduce the environmental footprint of electrical installations. Use energy-efficient appliances and lighting fixtures to reduce the overall electrical load on the house. Also, consider using recycled or sustainable materials for electrical wiring. Copper and aluminum can be recycled, and there are also environmentally friendly alternatives to traditional plastic insulation. By following these guidelines, it's possible to accurately estimate wire footage for large residential electrical projects and to ensure that the wiring installation is safe, efficient, and sustainable. The ability to properly estimate electrical wiring for any job will assist the electrician in ensuring accurate bids and profitability. Remember, it is always better to overestimate and have extra wire than to underestimate.